All right, good morning, everyone. Lovely day. Okay, we've got section 5.6 now, where our objective is to solve these application problems. And application problems are another word for story problems, where we're going to use rational expressions. So we read these stories over and put together a couple of equations, if you will, sometime, or one equation, depending on the problem. All right, so let's just jump in and try this out. I've got one number is twice another. The sum of their reciprocals is 2. Find the numbers. I think reciprocal is spelled wrong. I think that should be an O. Reciprocal. I'll check it out later. One number is twice another. The sum of their reciprocals is 2. Find the numbers. Okay, so we've got one number, x, is twice another x. So that's 2x. That's what they mean by that. So x equals 2x. The sum of their reciprocals is 2. So I got to take the reciprocals of x. The sum of them means to add them. And the sum of x, the reciprocal of x and 2x. So I don't want that. I want 1 over x plus 1 over 2x. That's going to equal 2. All right. Fair enough. And let's solve for x. So let's make our denominators the same. So I'm going to multiply the first fraction by 2 over 2. Second fraction I'll leave alone because it's already 2x. And then multiply this 1 times 2x. And that'll be top and bottom as well. Okay, our denominators are the same. So now I can concentrate on the numerators, and that's going to give me 2 times 1 is 2 plus 1. That equals 2 times 2x is 4x. All right, 2 plus 1 is 3 equals 4x. Divide both sides by 4. And I see that x equals 3 over 4. And that looks like our answer for that. If I wanted to check that answer, I could come over here and write up my original reciprocal problem, which is 1 over, instead of x, it's going to be 3 over 4, because that's what x is, plus 1 over 2 times 3 over 4. And check that out if it equals 2. Okay, 1 divided by 3 over 4, that's keep, change, flip. So this is going to be 4 over 3. Plus, let's see, 2 times 3 is 6, 6 over 4. And then I'm going to keep, change, flip that. That's 6 over 1 divided by 6 over 4 is 4 over 6. And that's going to equal 2 over 1. And that's it, just that it equals 2. So let's see, get my denominators to be the same here. I'll multiply this by 2 and the top by 2. So that's going to give me 8 over 6 plus 4 over 6. And that equals 12 over 6. That equals 2. And 2 equals 2. So that checks out. I'm just checking my answer there by plugging in 3/4. So my answer is x equals 3 over 4. Okay, our next problem. before I leave this, that did say find the numbers. So there's two numbers. So one of the numbers is 3/4, and then the other number comes from 2 times 3/4, which is 6/4, or you could simplify that by saying it's 3/2. So our answers are x equals 3/4, or x equals, what I say was 3/2. Okay, that's better. All right, example 2. Two families from the same neighborhood plan a ski trip together. The first family is driving a newer vehicle and makes the 455-mile trip at a speed 5 miles per hour faster than the second family, who is traveling in an older vehicle. The second family takes a half hour longer to make the trip. What are the speeds of the two families? All right, so now let's classify these problems as we're going about. We have 4 of them, I think, today, and so this is the second one, but it's a start. All right, we've got a problem where it's dealing with distances and rates. All right, so what pops into my head here, two families that are driving separately, so we've got something along the line of distance equals the rate times the time. That's a T. Distance equals a rate times the time. Okay, and there's two families here, so let's write it down twice. Distance equals the rate times the time. That's what I want there. I'm fussy about my T's there. All right, and let's fill in what we can. The first family is driving a new vehicle and makes the 455-mile trip at a speed 5 miles per hour faster than the second family. Okay, so that means the first family, I'll say the first family is over here, is going 455 miles at a rate R times time. Okay, we don't know what the time is. It does say something about the second family takes a half an hour longer to make the trip. All right, so this is good so far. This is all the information we have for sure. The second family, here, I'll write that, second family, and this is the first family. Okay, has a distance of 455 miles, same distance, right? Equals the rate. Now the rate is they're going 5 miles an hour faster than the second family. The first family is driving a newer vehicle and makes the 455-mile trip at a speed 5 miles per hour faster than the second family, who is driving an older vehicle. Actually, here's the first family, so they're the ones going faster. So let me change this to be the rate. And their rate is going to be R plus 5 times the T. Okay, and the second family is just going to go R times the T. Okay. All right, so now I've got my figures here, and there's one other thing I have to add, and that is about the second family who is traveling in an older vehicle. The second family takes a half hour longer to make the trip. So that means the second family, here's the second family, and here's the first family. I got to think about that. This will give you trouble too. So here's the first family equals the second family. And with respect to the half an hour, then let me clear this up here for a moment. Okay, so the second family equals the first family plus the half an hour. So I have to add a half an hour because it takes the second family a half an hour longer to get there. So I'm adding a half an hour onto the second family's time by putting it, the second family equals the first family plus the half an hour. So it's taken the second family a half an hour longer. So what I'm going to do here is I'm going to write this up as 455 equals r plus 5 times t. Okay, which I have up above. But before I do that, I want to solve for t. I want to get t by itself. And then I'll show you why, mathematically speaking. So the t, I'm going to divide both sides by r plus 5. And then this one for the first family is t equals 455 over the r plus 5. Okay, then I'll deal with the half in a moment. For this t, I want to get that by itself, so I'm going to divide both sides by r. Notice I'm using two different r's. Let me try and get that to be the same kind of r's. All right, so then these r's cancel, and I'm going to have t equals 455 divided by r. All right, here's first family, here's second family. Now, with the idea of having t equals 455 over r plus 5, and this t equals 455 over r, I'm going to replace this t with 455 over r that equals t. For t, I'm going to replace that. So it's going to look like this. It's going to look like 455 r plus 5 plus the 1/2 is going to equal the second family. And the second family is 455 over r. So I replace the t with the 455 over r. That's over here. And then the left side, 455 over r plus 5. And then I'm adding that 1/2, because that's what, remember, this is the second family, equals this as far as time goes. It took them a half an hour longer. Okay, and again, you're going to struggle with that in your head to say what's going on here, but believe me. All right, so this is our equation now, and we have to solve for r, the rate. All right, so let's do that. And it looks like I want to get my denominators to be the same. So we've got r plus 5 times 2 times r. So this r plus 5 is missing 2 times r, which is 2r. So I'm going to multiply that to top and bottom. I want to get my denominators to be the same, so they need those three components. R plus 5 times the 2 times the r. The 2, I'm going to multiply top and bottom by r times r plus 5. All right, and that's just by times 1, so that's not going to be a big deal. Remember, top and bottom. So I said r times r plus 5. I know I'm getting my denominators to be the same, so after a while of doing these, you can omit writing that. And then this r, I'm going to multiply by 2 times r plus 5. Because that's the only thing missing is the 2 and the r plus 5 that's multiplied. Okay, we've got a little messy stuff going on here. But what do we know? I know the denominators are the same. I'll write this here, and I'm just going to cross it off anyway. Same, 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 so they are gone. Now I'm going to concentrate on the numerators. So it's 2r times 455. Well, 2 times 455 is going to give us 910 r plus 1 times r plus 5. And I'm going to distribute that now. And that's going to give me r squared plus 5r. And that's going to equal 2 times, I got some distributing going on here as well. So how about that? How can I do that? 45, this is 2r and plus 10 times the 455. So 2 times r is 2r, and 2 times 5 is 10. So this is gone, and now I've got 455 times 2r plus 10. So that's going to be 455 times 2r is 910r plus 455 times 10, I'm just going to add a 0 onto the 455. 4550. And that's my equation thus far. I see I got a quadratic coming, so in my head I'm thinking ahead. I'm going to have to factor something. All right, let's go. I've got to subtract 910r. Let's do that first. And then how about, this is 0. Then I'll bring down my r squared plus 5r. That equals 4550. Subtract 4550, both sides. And my quadratic now is going to be r squared plus 5r minus 4550. And that's going to equal 0. So now on this problem, you're going to have to figure out how to factor that. I know that it's the easy one. Easy. So I got 2 parentheses here. All right, and I know I'm getting it equal to 0. So let's fill it up with what we can. How about an r here and an r here? I got a plus and a minus. And my 2 numbers that'll give me multiply to be negative 4550 and add up to be 5. And that is going to be 70 times 65. Okay, let me take a moment and check that. Yes, that's correct. So, figuring out my values for r, for this parentheses, r is going to equal negative 70, which we can't use because a rate can't be a negative number. So my answer for here is going to be that r equals 65. And that's my my answer. So the first family is going to be traveling at 70 miles per hour, and the second family 65 miles per hour. And then it checks out. Okay, but notice what I did. I gave each of them the distance formula and plugged in their criteria, what was happening with their circumstances. All right, let's go on to another one. So that was a problem. You read it, and it's a distance problem. So you think in terms of the distance formula. And the distance formula is distance equals rate times time. And usually they're comparing them to 2, in this case, 2 families. It could be 2 people, 2 racers, a lot of different scenarios. But that's what you need are the distance formulas. This problem is what we call a motion problem. Okay, and it's a distance problem as well because the current of a river is 3 miles per hour. It takes a motorboat a total of 3 hours to travel 12 miles upstream and return 12 miles downstream. What is the speed of the boat in still water? What is the speed of the boat in still water? Okay, so now I got some explaining to do. And when we're talking about the current, or in motion problems, where we are going downstream, which means we're going faster than when we're going upstream, and upstream means we're going slower. You got that resistance with the waves going against us. All right, so I'm still using the distance formula. So I could say that the distance equals the rate times the time. But the rate now isn't going to be r. I'm going to change the rate to be that the distance equals x plus y. That's my new rate, where the y is the speed of the current, and the x is the speed in still water. Okay, we have to work a few of these to understand it, but that's what's changing about this motion, because I have two different types, one going with, one going against. And then, of course, the t. So this is for going downstream. Now I need the formula for going upstream. And that would just mean my second equation would be that d, the distance, equals x minus y times t. All right, so key part now is that we want to get these equations equal to t. Okay, so how about we do this? Let's see, can I do that? The current of a river is 3 miles per hour. It takes a motorboat a total of 3 hours to travel 12 miles upstream and return 12 miles downstream. So that throws a little bit of a problem here. When it's talking about taking a total amount of time up and back, well, it's not going to be evenly distributed there. It's not going to take an hour and a half to go downstream and then an hour and a half to go upstream, because it takes longer to go upstream. Okay, sorry about that. Lost my train of thought. And so what we're going to do here now is I want to solve these for t, each of these for t, because that's basically the only variable I'm going to have left once I fill it in, other than the x, but that's what we're solving for. All right, so here I've got the distance. Well, let's solve for t first. So distance is going to be divided by x minus y. Okay, so I've got distance over x minus y, and that's going to equal this right side over here. I'm going to divide by x plus y. All right, and then what am I going to have here? These cancel out, and t is going to equal d over x plus y. All right, so d over x minus y here equals t, and d over x plus y equals t over here. So now what I can think of doing is, if t equals this, I'm going to substitute this for the t over here. Okay, which gives me that the distance over x minus y equals the distance over x plus y. Okay. Now let's fill in some information here. So on the left side, well, we know that it takes a motorboat a total of 3 hours to travel 12 miles upstream and return 12 miles downstream. So we know that the distances are 12 for both. All right, so it's going to be 12 over x minus y, and in the current of a river is 3 miles per hour. Okay, so that means y represents the current of the river. X represents the water, the still water. So this is going to end up being, for the left side here, it's going to be x minus 3. Okay, and now that's going to be equal to the distance 12 over x plus 3. Okay, so far so good. But now they've given us a problem that's probably probably one of the harder ones because it's not separated about the time. In this case here, it says the total time it takes to go there and back is 3 hours. So what I want to do is I want to take this where I was at. I have an equal sign there, but now because of this problem being the total time it takes there and back, I want to get this out of there and change it to a plus sign. I want going upstream plus going downstream is going to equal 3 hours. And this is my problem now. Okay, so let's get our denominators to be the same. X minus 3, x plus 3, and this is over 1. So over here I've got an x minus 3, I need an x plus 3. X plus 3 multiplied to the 12. And I also know it's downstairs too. I'm not going to write it. The x plus 3, I need an x minus 3. And that's top. And the 3 then, top and bottom, I'm going to multiply by x minus 3 times x plus 3. And also on the bottom, and therefore my denominators are all going to be the same now. And I'm going to take care of my numerators. Okay, I hope that's okay to do that. So now I've got 12x plus 36 plus 12x minus 36. This is that looks like a 13, but it's a 3. Okay, and now that's going to equal, now I'm going to multiply this all out. Let's see, I can FOIL these two, and I'm going to have, and then I'll multiply it by 3. So here I've got x times x is x squared. Outside is 3x. Inside is negative 3x. And last is negative 9. 3x minus 3x is 0. So I've got x squared minus 9. And then I got to multiply it by this 3. So that's going to give me 3x squared minus 27. Boop, boop. So here's my problem. Quadratic equation, I got to get it equal to 0. So everything on the left side is going to come over to the right side because the 3x squared is positive already. All right, so let's see, what am I going to have here? 12x and 12x is 24x. 36 minus 36, well, these are just going away. And this is going to equal now 3x squared minus 27. And then how about if I subtract 24x on both sides? And I'll have to rewrite this right side. So I'm going to have 0 equals 3x squared minus 24x minus 27. And I'm going to factor that to get my solutions for the x, which is the still water. So let's factor out a 3 here. And what's left is x squared minus 8x minus 9. See if I can keep going here. And, you know, it's equal to 0. And I just want to factor this trinomial here. So that's the easy one. They all seem to be. And I've got it equal to 0. And how about an x here? X minus plus. And what are my numbers? -9 plus 1. That works. And so my solutions are going to be x equals 9, because 9 minus 9 is 0, or x equals -1. Well, you can't have a negative time, so this is gone. So my solution for that is when the rate of the water in still water is going to be 9 miles per hour. The rate of the boat in the still water is going to be 9 miles per hour. Okay. All right. There we go. I may do another one since we got the weekend coming up. A couple more examples here of these. So be on the alert. Well, of course, I'll send you an email about it. Okay. Let's go on to our next one. Number 4. An inlet pipe can fill a pool in 10 hours while the drain can empty it in 12 hours. If the pool is empty and both the inlet pipe and the drain are open, how long will it take to fill the pool? All right, before we do this problem, I want to show you a simpler basic problem. Okay, and without that there, let me erase this stuff over here. Okay, here is a basic problem here. So let's see, I'm going to set it up how I do with work problems. Maybe 1 over something plus 1 over something else equals 1 over x. All right, so this, you can format your problems in this manner. All right, and then here's an example. Let's say it takes me 5 hours to paint a room. 5 hours to paint a room. 5 hours to do anything. Okay, let's say it takes me 5 hours to paint a room by myself. All right, so I would write that as 1 over 5. And it takes you maybe, let's say 8 hours to paint a room. So your 8 would go here. The 1 over the 5 and the 1 over 8 is representing how long does it take me to paint a room for 1 hour? How long? Well, what would it take me to paint if I worked on it for 1 hour? Well, it would take me 1/5 of the job if it takes me 5 hours to do the whole job. This is 1 over 8. It takes me an eighth of an hour, eighth of the job to do the job in an eighth of an hour. I don't know what I'm talking about. Okay. And then I end up with 1 over x. Nevertheless, if it takes me 5 hours, you 8 hours, the question is, how long does it take us to do it together? Okay, and that's the essence of the job. All right, takes me 5, takes you 8. How long will it take us both to do it if we did it together? All right, and this is what we'll figure out. I'll get my denominators to be the same again. So that means 8x top and bottom. This one would be 5x top and bottom. And over here it would be 40 and 40. 40 over 40. Because I've got the x here. And so all my denominators are 40x. Okay? And now I'm going to take care of my numerators. 8x times 1 is 8x, plus 1 times 5x is 5x, and that equals 1 times 40, which is 40. So now I got 8x plus 5x is 13x equals 40. And if I divide both sides by 13, then x equals 40 over 13. And that's how long it would take us to do the job if we worked on it together. And you could leave it. Does it make more sense to change that to a like a mixed number of some sort. Let's try it. Well, there it is there. So it would take a little over 3 hours to do that job if we worked on it together. Took me 8, took you 5, and together it would take us 3 hours if we worked on it. All right, so that's a basic problem in this, with respect to the setup of it. Okay, and we'll take this from here as we go forward. All right, that's our setup. Let's see, so now, of course, our problem here is giving us a little curveball. And this says an inlet pipe can fill a pool in 10 hours, while the drain can empty it in 12 hours. If the pool is empty and both the inlet pipe and the drain are open, how long will it take to fill the pool? Interesting. All right, so we've got the inlet pipe can fill a pool in 10 hours. So in 1 hour, it would take us 1/10 of the time it takes to do the entire pool. But now he's got a drain that can empty it in 12 hours. So that means we got a pipe going in and one going out. And so I need to subtract this 1/12. Because I'm subtracting. Okay? And then it's going to equal 1/x. How long will it take to fill the pool? Given it takes 10 hours to fill it and 12 hours to empty it. But this is my setup. This is what I'm ready to do. So let's do it. Here I'm going to multiply everything by 12x, top and bottom. This second fraction I'm going to multiply top and bottom by 10x. And this x I'm going to multiply by 120. 12 times 10, top and bottom. Denominators are the same. Then I've got 12x minus 10x equals 120. 12x minus 10x is 2x. That equal 120. Divide by 2. So x equals 60. How long will it take to fill the pool, given that it takes 10 hours to fill it and 12 hours to drain it? And that's it. Was that our last one? Yes, that's our last one. Okay, I think I'm willing to do some additional problems and maybe over the weekend. Tomorrow's Friday. What can I do on Friday? I think my wife's going to be gone, so that'll free me up here to kind of do some. I'll set us up pretty well with examples. Okay, kind of get as many examples as we can and see if you can get the feel for doing these application problems. If you struggle with it, don't worry about it. It will come, but it takes time and it takes a lot of practice. And the first thing I want us to do is learn how to set up the problems. If you get something like this in the example 4, that is called a work problem, and you want to set it up as I've done here, as I explained it here. Okay, got a couple other types of problems here. I won't tell you now. I'll wait till we come across it in our exercises and see if I can get it so when you do your homework you won't be struggling too much with it. Okay? All right. Have a good one, and we'll talk to you again soon. Goodbye.